In this video, I'm going to explain how the Simple Mail Transfer Protocol, or SMTP, works. If you're not familiar with how the Internet Mail System works, click on the link in the corner of this video to watch my video about it, and then come back here. I'll start with a short overview of how the protocol exchange works, explain the relationship between the envelope and content of an email, and take a closer look at status codes. Once I've done that, I'll go through a simple protocol exchange step by step from connecting to an MTA to a message being accepted for delivery. Then I'll look at some of the more advanced commands used for encryption, authentication and efficient data transfer. Finally, I'll give a brief introduction to how the content of an email is structured. SMTP is defined in Internet Standard RFC 5321 and was originally created as a line-oriented ASCII text protocol. Even though SMTP has been extended to support non-ASCII data, it still requires 7-bit ASCII characters for most of the protocol. In SMTP, the protocol exchange is implemented as a sequence of commands and responses that make up the submission of a message to an MTA. Each command has a verb followed by 0 or more parameters. Commands are sent on a single line terminated by the carriage return and line feed characters, also known as CRLF. Responses consist of a status code followed by additional information and a human-readable reason for the response. Now let's look at responses in more detail. Responses are normally a single line in the format XYZ space message CRLF, where XYZ is a 3-digit status code and message is a human-readable description of the status. An MTA can return multiple responses to a single command by replacing the space after the status code with a hyphen. The last line of the response must have a space after the status code. We'll see how this is used later with the hello command. Some responses also contain an enhanced status code that gives more information about the status. Now let's look at status codes in more detail. We have already seen that status codes consist of 3 digits. The first digit indicates the severity of the status, the second the category of the status, and the third the specific status in the category. The severity can have a value of 2, 3, 4 or 5, where 2 indicates success, 3 that more data is required, 4 that a transient fault has occurred, and 5 that a permanent fault has occurred. Transient faults are reported for error conditions that may be worth retrying. Permanent faults indicate that the command should not be retried. For example, 250 is the normal success status. 354 means that message data should be sent. 452 is returned when there is insufficient storage on the server to complete the operation. 500 means that there was a syntax error in the command. The SMTP protocol exchange creates the envelope and content of a message. The SMTP message envelope, like a piece of physical mail, contains the addressing information that allows the message to be delivered to the intended recipients. It also allows the message to be returned to the sender if it cannot be delivered. The content of a message is like the letter inside an envelope, and like physical mail, you don't need to know what the content is to be able to deliver it. However, in the same way that a physical envelope might affect what you can send in it, SMTP defines the rules for how content is included in a message. Now that we've covered some of the background to the SMTP protocol, we'll explain some of the details of its commands and responses by looking at the steps for a protocol exchange. An SMTP session begins with the client connecting to an MTA by opening a TCP/IP connection on network port 25 or 587. Port 25 is the original message submission port and is used in modern SMTP implementations for communication between MTAs. Port 587 is used for clients to submit mail to MTAs. I'll explain how encrypted connections are used when I introduce the starttls command later. SMTP MTAs use DNS entries called MX or mail exchanger records to determine which MTA to connect to for each recipient's domain. When a client connects, the MTA will return a response code of 220 followed by a greeting that typically identifies the implementation of the MTA. Once connected, the client starts sending protocol commands. The first command to be sent is the hello command, which is represented by the AHLO keyword followed by the domain or IP address of the client. The MTA responds to the hello command with one or more response lines that include the capabilities of the MTA. MTAs must also support the older hello keyword, which doesn't report any capabilities. A common set of SMTP capabilities are auth, starttls, chunking, 8-bit MIME, and binary MIME. The auth capability declares that the MTA supports authentication. The response will also say what kind of authentication is supported. The start TLS capability declares that the MTA supports the use of transport level encryption. The chunking capability declares that the MTA supports the submission of message content as blocks of data instead of as individual lines of text. The 8-bit MIME and binary MIME capabilities show that the MTA supports receiving non-ASCII data where allowed. For the initial introduction to the protocol, I'm going to only use the key commands used to send a message. The first command after EHLO in an unencrypted session is the mail from command. The mail from command is used to start a new message and declare who the sender of the message is. The sender address is used for replying to the message and by MTAs when generating delivery notifications. If the MTA is happy to receive a message from the sender, a response of 250 will be returned. Non-success conditions will be reported if the receiving MTA is unable or unwilling to accept the sender, for example if the sender is a known spam address. Additional parameters to the mail from command are used by MTAs when generating delivery notifications. The next step is to declare who the recipients of the message are. This is done using the recipient to command. Each recipient is declared in a separate recipient to command. If you send a message to 5 recipients, the recipient to command will be sent 5 times. Recipient to is the only command in SMTP that is normally sent more than once for each message. The MTA confirms that each recipient has been accepted by returning a 250 response. Like the mail from command, the additional parameters to the recipient to command are used when generating delivery notifications. The last of the basic set of commands is the data command, which is used to send the content of the message. When the data command is received, the MTA returns a 354 response, which indicates that the content of the message should be sent one line at a time. RSC 5321 says that the content must be completed with the sequence crlf.crlf, that is, with a line that contains a single full stop or period. To allow a message to contain content with the sequence crlf.crlf, any line that begins with a dot must have an additional dot sent at the beginning of the line. When each line is received by the MTA, it must check whether the first character is a dot and remove it. This process of adding and removing dots is referred to as dot stuffing. Once the message has been received and stored by the MTA, it will return a final 250 response indicating that submission of the message is complete. With those 4 commands, EHLO, mail from, recipient to, and data, it is possible to submit a message that can be delivered to the intended recipients. There are 3 additional commands that are part of enhanced SMTP that are typically used when sending messages. These are the start TLS, auth, and BDAT commands. The start TLS command is used to initiate the transition to a secure connection once an initial unencrypted connection has been made to an MTA. The start TLS command must be sent after the EHLO command, since the response to EHLO will show whether start TLS is supported by the MTA. After the command has been sent, the client and server negotiate the transition to a secure connection. Then the SMTP conversation restarts with the EHLO command. EHLO must be sent again because the MTA may advertise different capabilities when using an encrypted connection. Aside from using start TLS to establish a secure connection, there are no other changes to the protocol used to submit a message. Using start TLS only ensures a secure connection is used. The content of the message must be encrypted separately if required. The auth command is used to authenticate the connecting user. There are various forms of the auth command depending on how the user's credentials are to be transmitted, but importantly, auth should not be used before a successful start TLS command to avoid sending unencrypted credentials. Auth is one of the capabilities that may not be advertised by the EHLO response before start TLS has been completed successfully. The BDAT command provides an alternative to using data to send message content. It can be used when the chunking capability is reported by the EHLO response. Unlike data, which is line-oriented, BDAT is used to send blocks of data. This makes it much more efficient because the receiving MTA does not need to read individual characters to find CRLF line terminators, and no dot stuffing is required. One or more BDAT commands can be used to send the message content. Each BDAT command specifies the number of bytes to be sent in the chunk and whether it is the last chunk. Once the BDAT command has been received by the MTA, it reads the specified number of bytes from the network connection and then sends a 250 response if the data has been stored successfully. A 250 response to the last BDAT chunk means that the message has been successfully received and the client no longer needs to retain the message. When combined with the binary MIME and 8-bit MIME extensions, BDAT allows non-ASCII message data to be sent. Now that we've seen the normal sequence for sending a message using SMTP, let's see what happens if we try to send commands in a different sequence. If we send mail from before the EHLO command, we're told that the command is not valid in the current state. The same thing happens if we try to send RCPT2 before we've sent mail from. If we try to send data or BDAT before we've sent at least one recipient, we're told that no valid recipients have been received. This illustrates another aspect of SMTP. The sequence of commands and responses are what make it a reliable process. To ensure that all the required steps are performed, it is not valid to send commands out of sequence. Likewise, to ensure that messages can be transferred reliably from clients to MTAs and between MTAs, it is not valid to proceed to the next step until a success response has been received. The most important part of implementing an MTA or SMTP client is ensuring that messages are not lost during the submission process. A message can be lost if the submitting client deletes its copy of the message without receiving a 250 response to the data or BDAT command. Therefore, receiving MTAs must be careful not to issue the final 250 response until the message envelope and content has been successfully stored, and clients must not delete any information about the message until the 250 response has been received. Similarly, clients must not assume a recipient will receive a message unless a 250 response has been received to the RCPT2 command containing the recipient's email address. If these simple rules are adhered to, SMTP provides a reliable mechanism for submitting and delivering email. To finish this introduction to SMTP, there is one last common command to introduce. The quit command is used to close the connection to the MTA. When the MTA receives quit, it discards all data for any incomplete message in the session, sends a response acknowledging the quit command, and closes the connection. The SMTP standard defines how the content of an internet mail message is submitted to an MTA, but beyond some limitations on the character set that can be used for the content, it says very little about what the content must be to be a valid internet mail message. Another standard, RFC 5322, defines the structure of the content of a message. It states that an internet mail message is composed of two parts, the header fields and the body. The header fields describe properties of the message, such as the subject and the date it was sent. The body contains the contents of the message, which is simply a set of lines of ASCII text. The header fields in an internet mail message are lines of text followed by a blank line that marks the end of the headers and the start of the body. Header fields are comprised of a header name and value separated by a colon. For example, the subject header would be as shown. Some common headers are from, to, CC, subject, date, and message ID. The from header is the visible value of the sender of the message. This is normally the same as the value of the mail from command. However, it does not have to be. The values of the recipient to commands contain the values entered into the to, CC, and BCC fields in a mail client. The to and CC values also appear as header fields, but the BCC values are not represented in the headers because they are intended to be hidden from the recipient. The body of the message, as described in RFC 5322, appears after the headers and is a collection of lines of ASCII text. Since ASCII text cannot directly include things like formatting, colours, inline images, attachments, or even non-Latin characters, another set of standards exists to define how we can use those things in an email. These standards, known as Multipurpose Internet Mail Extensions, or MIME, are used to define how we can represent complex, rich messages within the limitations imposed by the Internet Mail standards. The body of an email is often encoded using HTML, which defines how we can represent things like text color, size, layout, and non-Latin characters, while only requiring ASCII to be used for encoding. Attachments are encoded using base64, allowing binary data to be represented as ASCII text. The MIME standards define how a body and attachments can be included in a single message. Looking at how message content is structured in more detail is beyond the scope of this video. Okay, that's it for this introduction to SMTP. I hope you found it useful.